The biggest buzzword of the last 6 months is MCP gateway. Every major infrastructure company just shipped one. Docker, Cloudflare, Kong, AWS, Microsoft. Most of you don't need one. And if you're reaching for one to keep your agents secure, it isn't fixing the thing that actually gets you breached. Right now, your agent is holding a real API key in a place that you don't control, while it runs instructions from the open internet, and an MCP gateway doesn't touch that. So here's how an agent can get you in trouble. Your agent reads instructions. It reads prompts. And some of these prompts come from you. A lot, however, come from other places. They come from whatever it reads. So this might be a web page, it might be an email, it might be GitHub. Now, an attacker could write one of these prompts as well. For example, a GitHub issue. And the attacker can hide instructions inside of that GitHub issue or inside of that web page, and your agent will follow them as if you had written them to your agent. That, my friends, is prompt injection. Now, if we add in keys, that same agent is holding these live credentials to things like Stripe, maybe Supabase, Notion. So these injected instructions tell it to grab the key and send it out. This is prompt injection leading to credential exfiltration. And this is the #1 threat to agentic systems today. Now, Simon Willison calls this setup the lethal trifecta. So we've got 3 things in one agent. We have access to private data, exposure to untrusted content, and then a way to send data out. Every useful agent has all 3. And this idea of credential exfiltration isn't just hypothetical. In May of 2025, researchers showed it on the GitHub MCP setup. A stranger opens an issue on your public repo with hidden instructions. You tell your agent to look at its open issues. It reads this issue and then it pushes your private code into a public PR, and nobody had to click anything. This is just an example of a prompt injection. And I also want to note that this isn't actually unique to agents. This is the same pattern anywhere that untrusted code runs next to a credential. So CI pipelines have been getting hit this way for years. For example, if we think about the March 2026 Trivy incident, Trivy was a widely used scanner in GitHub Actions. It was compromised, and attackers repointed 76 of these 77 release tags to a credential stealer that harvested each of these pipelines' credentials. And this was before the actual scan ran, and then the scan just ran like normal, so people didn't even know. More than 10,000 workflows referenced this. So the tool that teams trusted to catch this thing was the thing that was stealing or exfiltrating keys. So the industry's answer is the MCP gateway, and this sits in front of your MCP servers. It controls who calls what, it logs some stuff, has auditing, and some even hold MCP credentials, so this is definitely useful. And then all of our agents route their requests through the gateway to access those MCP servers. But this is called an MCP gateway for a reason. It's opinionated around MCP. It assumes that your agent is an MCP client and it governs that one protocol. The issue is your agents don't only speak MCP. It makes REST calls, it uses CLI tools like the GitHub CLI, it hits local processes, and the MCP gateway waves all of that through. And the thing that you actually want, the thing that we talked about earlier, which is no usable credential ever sitting in the agent, was never an MCP feature. Now, this is a feature of something called credential brokering, so don't start by picking a gateway. If what you're trying to solve is credential exfiltration, like we talked about earlier, the tool isn't an MCP gateway at all. It's this credential broker that sits at egress, and it doesn't care which protocol your agent speaks. So our fix is that the agent never holds the key. The broker holds these real credentials, the agent runs with a placeholder, or maybe it runs with nothing at all. When the agent makes a request, this broker is going to inject that secret on the line. So when the agent makes a request, the broker injects the real key onto the wire at the last moment, and the agent never sees the real key. Now, if we think about where should this broker sit, every path that your agent takes, whether that's MCP, REST, or CLI, it's all going to bottom out in an outbound HTTP, HTTPS request. So you put this broker here at the egress boundary as a proxy. Now, if you've ever used MITM proxy to inspect HTTPS, it's this same man-in-the-middle position. Except in this case, instead of reading these requests, it's actually reading them and injecting credentials in them for these upstream APIs. Again, one proxy is going to cover all these different interfaces because they all leave in the same way. It ends up being HTTP. Now, for this to hold, obviously our agent's traffic has to actually go through the proxy. So we lock egress at this network level so that the only door out is through the credential broker. Let me show you one. This is Agent Vault. It's open source, and it's exactly this, a credential broker that sits in between your agent and the upstream APIs that it calls, and it injects those credentials on the wire. So I've got an instance of Agent Vault running here, and I've set up this service for api.stripe.com. Here we have it saved for any call to api.stripe.com. The real value of Stripe key will be injected. This is my credential broker. And I also have a Claude set up that's routing through my credential broker. So Claude has no real Stripe key anywhere it can reach. So I'll tell Claude, get my Stripe test balance. Here we can see Claude is aware I'll call it using a placeholder key since the proxy injects real credentials on the wire. And here I can see that the call worked. So the broker swapped that real key on the wire and Stripe authenticated. The agent never actually touched the secret. So if I go back to my broker and I click on logs, I can see here I have a 200 for api.stripe.com. And with this, I have the credential that was used. If I had set up an agent identity, I would have my agent showing up in here as well. Now, protecting the credential is the win, but it's not the only thing you get. Think about everything it takes to secure an agent. Identity, authentication, authorization, audit, and one control point where you can enforce this. The broker gives you all 5. Your vault is set up to only allow certain agents, so it has identity. And then it decides to inject or not inject based off of these services, so you get authentication and fine-grained authorization. And every request converges on this, so it's your control point. And of course, our audit logs are just writing down everything that flows through. So a gateway, as we discussed, would add identity, authorization, and audit on top of this one interface, MCP. The broker, of course, does the reverse. It protects these credentials first, and then it gives you the same auditability and governance across all of these interfaces, not just MCP. And you also don't have to take my word that egress is the right place. Let's look at Anthropic, the company that created MCP. Anthropic ships an agent inside Slack called Claude Tag. Now, if we look here, Claude Tag runs in a sandbox, and to do the real work, it has to access GitHub, any other HTTP API. Now, how does Claude handle the credentials? Not with an MCP gateway. The sandbox itself, we can see, holds no credentials. When a request goes out, we have this agent proxy that injects the credentials, and then in their own words, the model and the sandbox are never given the key. So every request is checked against an allow rule, and then every action shows up under a service account, and you get a clean audit trail as well. We've got credentials injected at egress, never handed to the agent per request rules, audit by attribution. This is not an MCP gateway. It's a credential broker at egress. The company that invented MCP protects its own agent exactly this way. Now, one honest limit that I have to be clear about, this does not solve prompt injection itself. A hijacked agent that can already read your private data could be steered into exfiltrating that data. What the broker closes is credential exfiltration as opposed to data exfiltration. This is an important distinction. So next time you stand up an agent, ask yourself, do you want to lock yourself into one opinionated MCP-shaped pattern to get halfway there? Or do you want to start with stopping credential exfiltration at the HTTP layer, and then you get all of the other agent governance that comes with it? The tool to try is a man-in-the-middle proxy and a credential broker like Agent Vault. Start with the credential and identity, authorization, and audit tag along. Agent Vault is open source. I'll leave a link to it in the description. And if you're building this in a different way, leave it in the comments. I read every single one. Thanks for watching, and we'll see you in the next one.